Hi guys. So in this video, we'll finally build an AI agent. We'll use OpenAI GPT model, probably GPT-4o, and we'll build everything from scratch. Of course, just using the API. So OpenAI API will still be there. Rest everything we'll do ourselves. We'll write the prompt exactly how we want, and we'll also write some tools that we want our agent to use without using any framework. So this is not about LangChain or LangGraph or anything. This is just us using pure LLM and building an AI agent. So let's give a little story to it. In some previous videos, we had built a chatbot, and this was an e-commerce chatbot where we sort of mentioned these products in the system message itself, so that our chatbot has information about these products and it can answer user queries if they asked anything about this product. But we said like this is not the way to go about it. Like we can't hard code all these product info in the system message. So we'll basically be using a function for this, which retrieves products. So let's start with the code. We'll first import all the things that we need. These are the usual imports, OpenAI and .env for loading the environment variables. We are also importing regular expression library. We'll see ahead, like when we use some prompts, we want to extract some information using regular expression. So I'll show you like where it's used and how it's used. We'll also quickly initialize our OpenAI client. And then now let's get started with defining the tools that our AI agent can use. These will just be bunch of functions. So let me paste like the first function. This is just a search product function. So it will take in like a product query, and it will return like some products related to that query. Now what I did is I just went on this rapid API. You can also search for rapid API. It's like an API marketplace where you can find some APIs that you need, which are publicly available, and for some rates it's free within some threshold if you call some number of times. So you can look through these marketplaces as well, or any other API that you have that you want to incorporate in your agent. But I just found like this Amazon product search API in rapid API marketplace. I'll also put down like the rapid API link for this API that I found for your reference. But at a broad level, it just takes like product query, and this is the payload that I just got from rapid API. I've just replaced the product query here. I'm not going much into detail. It's like which page do you want, which country do you want, and so on and so forth. Like, but we just get like some few products. And this is like my API key, rapid API API key. Don't worry, I'll either delete them or change them once this tutorial is published. So you can't really use the same API keys. You'll have to get your own. But it's free to some extent, so you can explore rapid API. So what we'll do is we'll just call this API, and I'm just clipping the response till three products. So first three products will be sent. That's all. This is just for demo purposes, like the AI agent that we are building. So just handling three products is enough. Otherwise, the message is getting too big. What this function does is it takes a product query. Let's say you want to search for a shirt. So it will take in a string shirt, and it will return three shirts that are available on Amazon. So this is our first tool. Let's define some more tools so that our bot is like a little smart, and not just like searching the product, but actually making the purchase as well. Let me paste the remaining tools. Yeah, so I've defined like small functions now. Not all of them are using APIs now. Only the search product function calls an API. Rest all are just pure Python functions. So one tool we have is add to cart. Like if user has selected a product, I'm just using like a local in-memory variable called cart. But you can imagine like even here you can put an API call which actually calls your DB and adds to cart for that client and so on. Like This can be very complex function. I'm keeping it very simple, like it just appends to this list and returns true. So it takes in like product ID, which product you want to add to the cart, and how many of those products that we want to add to the cart. We have another small function called summarize cart. So if anyone asks like, oh, what do I have in my cart till now? We can call this function and it just returns the cart. And the next tool we have is buy product. So buy product right now, it only takes payment method, and whatever you have in your cart, basically that would be purchased. But this is like a dummy function that you can see. It's like a not even bones, basically. Even this, like you can imagine like making actual API calls or hitting your DB or actually executing the logic. This function can get really complex. We have kept it simple so that just to see like how it works in our e-commerce bot. The point of this tutorial is not to build amazing tools, but to build an amazing AI agent that can use these tools, right? So I'm keeping these tools very simple for now. If the payment method is cash on delivery, it will just respond saying, hey, order confirmation is sent to the email or something. Or else if it is not a COD, then it will generate like a payment link. So this also is another function that we defined, generate payment link, and we send the cart. This is a global cart. Let me put global here. Yeah, so this is the global cart variable. Again, this is this list that we'll use. It's a simple list, and we'll send the cart in generate payment link, and it generates a payment link. So based on payment method. Yeah, actually I should send the payment method as well. These are all dummy functions, so we don't have to worry about it actually working, the function actually working or not. But you get the idea. Like basically based on the payment method, you'll generate a payment link. If they chose a credit card or something, they can click on that link and make the payment. So you'll get a payment link here, which you'll send as response. This is not a tool, this is a util function. So this generate payment link we will not give to our AI agent, but only these above 4 functions. So this is one tool that we'll give to our AI agent. This is the second tool, this is third, and this is the fourth. So our agent can search for products, our agent can add products to a cart, our agent can summarize a cart, and our agent can make a purchase for that cart, right? This is a util function which one of the tool uses. This is pure code. Now that we have defined these tools, we'll start writing the actual prompt. So the reasoning loop, the React prompt. Let me just paste the React prompt and we'll go through it once. It's a fairly simple prompt, I would say. Like I've kept it like very simple. So you'll run in a loop of thought, action, pause, and observation. So pause is just something that I've added. I've seen it there in like some of the React prompts that people write. So you can also think of writing, or you can remove pause as well. But thought, action, and observation is what we have discussed in last video as well. So it will always run in a loop. This is the loop: thought, action, observation. At the end of the loop, you will output an answer. So when the loop is complete, we just make it output an answer. That's it. Use thought to describe your thought about question you have been asked. We are just telling it what thought means, and we are asking it to think about the question. And then we are saying like use action to run actions available to you, then return pause. Yeah, this is self-explanatory, I guess. Observation will be the result of running those actions. And then we give it the list of tools that are available to it. So your available actions are the functions basically that we defined above. We are describing it to some extent in this prompt. So we have a search product function. The way we use it is call search product colon the product query, which is a string. So for example, search product Samsung Galaxy returns a list of product matching the given search query. So this is how we are defining tools to our AI agent. Basically in the prompt we are writing like how to use the tool, what will you get after you use the tool, you'll get a list of products and all. And similar way, like we have defined these other three tools as well. Add to cart is give the product ID and how many quantity that you want. So this is an example usage, and we are saying like it just returns a confirmation stating that it has been added or not. Summarize cart. So here there are no inputs. I've tried to keep it varied so that you realize like how can you use different tools with different inputs. So some tools may not require any input. So I've also included that example. So this will be null, and it'll just send you the shopping cart so that you can summarize it to the customer. And finally, we have byproduct. Now, byproduct is also a little special because the input that you can give is an enum. So we are saying like it can be the input can be one of these values only: COD, credit card, debit card, UPI, net banking. So these are the only payment methods that we accept. Byproduct will be called with the card and COD. Actually, our byproduct only accepts payment method. So let me remove the cart. We don't need the cart. We have access to cart through our global variable here. In a realistic case, we will always have the client ID where the application is running. So using the client ID, we ideally fetch the cart from our actual DB. So rather than accessing the cart like this, we'll actually be retrieving it from the DB based on the client ID on which the app is running, right? That will be the real production case scenario. Yeah, so byproduct will only take an enum of this payment method, that's all. So for example, byproduct is called with COD as option. So it'll attempt to make the purchase and return a confirmation message or link for the method to COD or a payment link basically. So this is how we define tools to our agent. This is just a prompt. Till now we have asked it to run in a loop. We have defined all the tools, and basically in this last section of the prompt we give it like an example run. So this will clarify to you as well how exactly the prompt is going to run, or how exactly we want LLM to respond. So let's say this is a question that user has asked: I want to buy a Samsung Galaxy phone, can you help? So it would output like a thought saying I should search for Samsung Galaxy phones, and then it should say action. So this is the loop that has started: thought, action, and action that is taking is search product with query Samsung Galaxy, because user has asked for Samsung Galaxy phone, and then it just says pause. Now the observation is the search returned the products. So let's say one of these, this is one product that was returned, and these are like the details for it, like price, color, whatever. So finally the answer, since we got the product, the answer will be the search resulted for Samsung Galaxy phone has been displayed. If you want to add phone to the cart, please specify the product and the desired quantity. Great. So it's returning the product that was observed by the tool, and it's asking user like what are the next steps, like do you want me to add it to the cart or something. Now that is done, user says like yeah, add this phone to the cart. The user requested to add product to the cart but did not specify quantity. I should clarify the quantity. Now add to cart takes quantity as an input. So here we mentioned like product ID and quantity. So when user says like he wants to buy a Samsung Galaxy, this particular phone, but he didn't mention the quantity. So this is something that happened actually while I was testing and I was building this. It was assuming the quantity and going forward with adding one phone to the cart. But then I just added this example saying like if quantity is not mentioned, go and ask the user, right? So that's why I added this example, and hopefully it asks us rather than assuming the quantities and all, because that's how we desire the behavior of this bot. But if you want, like, you can also give examples in a different way, suggesting make decisions and just add it to the cart irrespective of the quantity, and don't waste time asking the user and all. So in this example, user says add two quantities, and that's when the AI thinks like, okay, I will now add this specified product to the cart, and then it will call add to cart with the product ID and with the quantity too. And this is the action. It will just pause for a while. We'll actually execute that action, and the thing that we'll return to it is products are added to the cart successfully. And then the final answer our bot will give is Samsung Galaxy has been added to the cart with quantity 2 and so on. So this is a simple prompt. Like, I am pushing this on GitHub. You can find this. The link will be in the description. So you can also slowly go through the prompt and see what it does and how it's written the way it is. Let's continue with the remaining code now. So let's first define the actions that we have. Like, let's define a map. Now what it does is in the prompt, when it outputs, like, let's say add to cart, so we need to find a way to actually map it to the actual function called add to cart, right? So you see this is the key, which is a string, but variable, but the value is the function add to cart. So the functions that we defined here, add to cart, this is what is referenced to in this dictionary. So these are the known actions. Like, if the prompt outputs any one of these, it will map to these actual functions that are present in our code base. And then we'll define like a small regular expression for parsing out actions. So whenever our bot or LLM outputs an action, we want to parse out this actual action that it wants to take and the input values that it wants to take that action with. So this is the regex to do that. Like so it will have action colon, and then there will be some characters here with a followed by a colon, and then there will be some inputs here. So you can take some time, maybe put this regex through ChatGPT to explain it to you, but this is like a simple regex which will parse out that action and tool and input for you. Great. So I'll be pasting like a big function now. This is the actual React loop. I'll explain what it does. It's a fairly simple but slightly complicated as well. So let me go ahead and let me explain what is happening exactly. Now, when we enter the React loop, first of all, we'll go like till some max number of turns. So it will think, it will act, it will observe, think, act, observe, think, act, observe. So it can only go till like some max number of turns. For now, we have defined it till 5. Otherwise, it just keeps going on and on. React loop history you can ignore for now. I'll tell you what the use of this is. But this is where we define our message list. So this is where all the messages will keep getting appended. Now the very first message is the system message, which is the actual React prompt. So this prompt that we had written, it knows like what is to be done, how am I supposed to run in a loop and all. So this is the very first message in our loop. And what we'll append here is this will be a question message. So this will again be a user message which will come as input to this function. So you can imagine question message to be something like this will again be a list because we are adding it. This will be user message, and here there will be actually be a question like I want to buy something. So this question message will look something like this. That's why so we'll add like a system message and then a user message with actual question. For now I'll remove this because it will come as input to this function. So I hope till here it's clear. We are just starting to create the message. So now we'll start the loop. We'll actually enter the loop, and then what we'll do is we'll first get the response from our LLM. So we are using GPT-4o. I had tried this with GPT-4o mini. It doesn't work that well. So I've switched to 4o. You can also do 4 if you want. Even 4 I've tried, it works really well. So what we are doing here is we are just sending these set of messages, which is just system and user message, to 4o, and we are getting the response. And now once we get the response, we are appending it to the same message loop first. So we are appending it with role as assistant, and whatever result we get, we are taking it and appending it back to the message. React loop history, I'll again come back. So this is some history that we keep track of, but this is not related to the logic. It's just for logging purposes that we are using. I'll explain this loop history variable later on. But for now, you only need to worry about these messages that are being added. So till now we have a system message, a user message, and now one more assistant message is added to the message loop. And now once we add the message, we are also logging what was generated. So maybe this would be like thought, action, and pause, right? So this will mostly be generated, thought, action, pause. And now what we'll do is we'll take this result and we'll actually run it through the regex that we have defined. So this regex that we defined, we'll pass this result and match through this regex and get the actions. Now, if there are actions, only then we worry about observation, else we will return this result as it is. So if there are no actions, maybe the loop has ended, maybe LLM has said, okay, this is the answer, and we return this answer as it is here, else. Now let's see the case where action is present. If an action is there, the way we have extracted this using regex, we can do dot groups and we get action and input from this regex itself. Again, so if action is present, we will extract out action input and action that has been extracted using this regex. So basically this is the action and this is the action input, which will be extracted out from the regex itself. So we add like a small error handling here. These two lines are not even needed, but sometimes the LLM gives like random actions which are not even present in the list. Now we know for a fact that in this map, our action should be present, only then we'll be able to execute it. So we have added like an exception here. So if action that needs to be taken is not present in known actions, then we raise an error. We hope that we never encounter this error, but LLMs being LLMs, they sometimes give actions which are not even described in this prompt, right? So that could happen sometimes. So now that we have passed this error, we have like a valid action and some inputs that we can pass. So this is just a logging statement that we'll call, saying that, hey, we are calling this action with these inputs. And now to actually call the function, what we'll do is we'll get the list of inputs that we have. So we are splitting it with comma. So you see like here an example, add to cart. So this is a string. We'll split it with comma so that we get like two different inputs or two different params. So this is what we'll get here, input for input in split, and if input is not null. So just to handle this null case as well, like say for example summarize cart, it says null, then we don't really have any parameter, right? Summarize cart, if you see here, it doesn't take any input, so it doesn't really need anything, and that's why if it's null, we will just ignore it. Rest everything we'll add it in, it'll work normally. So this is like a generalized version of parsing inputs. So we have taken it in a list, and this line is actually calling the function now. So known actions is a dict, known actions. We'll go see what action to call. So this action that our LLM has asked us to perform, we'll get the function from here. So this will return the actual function, and we are calling that function, and we are using this star to unroll all the params that we passed in this list. So this list contains all the params, and yeah, this is how we'll actually execute the function, and observation will basically be the thing that the function will return. So once we get the observation that our function has returned, we'll just log it so that we also get to see what our function has returned, and we'll create like an observation prompt. So the actual output of the function we'll again give back to the LLM, saying that, hey, this is the observation. We'll put the observation here, and we'll append it to the message under user role. Yeah, this role is somewhat fine. Like you can give assistant as well. It doesn't make a lot of difference. You may carry out like extensive experiments and experimentation and all to actually see like how role is played and all. But just to get things working, user or assistant both are fine. Preferably we can give user itself so that it knows like this is coming from outside. But this observation prompt we create and we just add it to the React message loop. Now let's say LLM had asked us to perform an action here. We will go inside this if block. We'll add the observation to the loop, and we'll again go back here, right? Now once this observation is added, you see we again call this LLM, so that it's like LLM asked us to perform an action. We perform that action and we are appending it as an observation now. And now we are asking LLM again, like, what do you want to do? Do you want to throw a final answer looking at the observation, or do you want to use more tools? So this loop can go on. Again, LLM will respond with something, and we are appending it again back. So LLM, when we make this LLM, we are giving like the complete message history. So LLM always has the complete message history that, hey, this is the React prompt, this is what I asked to perform, this is what action I asked to perform, this is the observation, and then again it will start printing thought like, hey, I want to perform another action, or I have reached the final answer or something like that. So this will go on. So this can like go on, like it can ask us to perform more action till it doesn't ask us to perform any other action. It'll give the answer. We won't go inside this if, but we'll go inside this else and we'll return the result. React loop history. This is just keeping track. If you see, like we are not really using it. We just initialized it, adding messages to it, and we are returning it. The only thing that we have excluded in loop history is this system message and question message. That's why we have made it separate. Otherwise, we could have returned loop message itself. You'll see ahead, like it's useful for us to keep track of history when we actually build a chatbot using this React loop. Yeah, for now it's fine. Like you don't have to worry too much about this for now. So let's run this. So now that we have defined our React loop, let's define a final function to actually start chatting and start sending our user query. So this is the function that we'll use. It takes in the user query and it creates this message using role and user. And once this message is created, it will send as input to this React loop that we defined above. If you remember, it takes in a question message, and that's exactly what we are sending in here. This is the query that we'll send, and we'll in response we'll get like a response and React loop history as well. So whatever answer that it generated after doing the loop, and the loop history, everything that is there in the history, right? So response, we assume that answer is there, so we'll basically strip out answer, and whatever is remaining after answer colon, we are returning it. That's a simple chat function. Like this is just to actually use the loop. So great, let me start talking to our chatbot that we have built, which has access to tools. So I just put a small query saying, hey, I want to buy a pair of pants. Actually, let me keep it small. LLMs are smart enough, right? Okay, so I've added these logs here, so we know exactly what is happening. Now when we print this, it means it's entering the React loop. So everything in between start and ending React loop is the actual React loop code that is there. So from here till here, it's happening within the React loop. Let's see what happened. So result of calling React loop, React prompt loop is, so this is where it starts. If you see, result of calling React prompt loop, and then this is the first result that we'll get. So it started generating some thought. I should search for pants to find available options that the user might be interested in purchasing. And it calls action of search product with pants. And then we have this another log saying calling tools search product with input pants. So search product is actually called, And so you can see here calling tool search product with input pans, and in observation we log the actual response of the function. So from here till here, if you see, this is the actual response we got when we call search product function. I mean, this is a API response. Like if we see the search product function here, so if you see, we are returning 3 products. I mean, this is an API response actually, which has like product info. Let me actually quickly go through the Rapid API request that we are using. So this is the product search API that is there. Let me show you the example response. They are showing like an example response where there are like 16 products that are retrieved, and for each product they give like these values, right? So ASIN number, so it's kind of like an ID, I guess. And then there is product title, product price, and so on, like all these Amazon kind of schema, I think. But they have like these information returned for one product. So like this they have returned 16. In our code we are only stripping it to 3 products, and that's what you see here in the response. So this is a list of 3 products with those keys that you saw. Each product has those keys, ASIN number, and then there is product title and so on. Now this list is as it is passed through LLM. Now when we say observation, we are also adding this exact observation as is in the string and appending it to the message loop, right? So this is where the loop will end, and it will again go back to the LLM. So result of calling React loop. Now it generated it didn't generate a thought, but it directly generated the answer. Here are some options to consider, and it has nicely formatted the list for us. So if you see like Wrangler authentic men's relaxed first stretch, so it's just putting this title here, giving us like some other parameters. In fact, we can also actually go to this link and see. So it actually is a pant, like you can go to the page, Amazon page is also there. So yeah, the API works basically, and even the LLM has generated this whole thing, like it formatted correctly for us. And then it says, please specify the pair of pants you are interested if you want to add them to the cart with desired quantity. And this is the end. So if you see, like this is the answer that was generated, there was no action. That's why we came out of the loop. If there was an action, we would have gone in this block, and then loop would have continued. But because there was no action, we returned from this function and we cut the loop. So these were internal logs. Now when we cut the loop and the final answer, that is response. So this result is the final response, right? Response for the final message, which contains the answer and no actions. So when those are coming in, we take the response and we strip out the answer part, and we present it to the user. So this would be the actual part that a user would see when they are inputting a query like this. Rest everything is just logs for us to see what is happening under the hood. But after the ending of React loop, this is what the actual output that the user will see, who's using the chatbot. So yeah, it's basically the answer that we print, the answer that is here. We just strip out this answer and we print this much part. So yeah, we are getting the response now, and it's asking like which one do you want to add and all. Let's call this chat function again, and let's say maybe by the second one. Okay, great. So now what happened? Great. So it again started the loop now. This is the starting of the React loop. So the user wants to buy the second item in the cart. First, I need to check the contents of the cart, identify the second item. Summarize cart, null. Okay, it went in calling for the summarize cart. The result for calling summarize cart. So observation was empty cart because we really don't have anything in the cart. And then we call the prompt again. The cart is currently empty, so there is no second item to purchase. I should inform user about the cart is empty and assist them in finding and adding the product. So your shopping cart is currently empty. That is the answer. So the thought produced after taking the action was cart is empty, inform the user, and it's spitting out an answer saying cart is empty, do you want to purchase something? And we strip out this answer, and this is the actual final answer that we get. This is all logs for us. Why did this happen? Well, simple reason, it doesn't have access to the history. When we wrote this chat function, this React loop happens very independently. We are not keeping any track of message history, so it doesn't even know we searched for pants and these are the results that it responded us with. Basically, we need to define the chat function in a better way. We have to give it access to the message history so that it has some context of the conversation about what was talked about till now, and hence what should I respond with. Now to do that, now this is where React loop history comes into picture. Let me rewrite this chat function. So if you remember from previous tutorials, while building a chatbot, we discussed like how to keep track of chat history. So let's say this is the global message list that we'll use to keep track of chat history. Here again, we'll start with the user query, the same chat function, but we'll keep appending to this message list now. So as soon as we get the query, we'll append it to the messages. We'll call React loop with this message list now. Previously also it was a list, but it was a list that was created only for that query, right? And now it's like a list that is appending, like, so you'll see like for now we only append one user query, but when we get the response, when we get out of the React loop, we will add this React loop history as well to the messages. And then next time when we get a query, we have all the history there. We'll attach the next query and we'll again send it to the whole React loop so that it can answer based on the history as well. And this line is exactly the same as previous function. So this is the only small tweak that we do to actually add like that historical component so that it has some context. Now let's talk to the bot and see how we get the results. Let's ask it something fancier this time. Let's ask it for a shirt and maybe like blue in color. So it's running like the thought has started coming in. I need to search for blue shirt to help user find product they might like to purchase. It's calling search product with input as blue shirt. And now we are calling this tool. So the tool responded with let's say 3 shirts that are there, and amazing. So when we give this observation back to the prompt, this is the result that it generated. Here is the blue shirts that might be interested in. If you see here, it didn't even generate like answer colon. Ideally it could have, but it didn't. But it's fine. Like our code is fine with it. It can handle it. Since there is no action here, it will come out of the loop irrespective of answer is generated. So it works. Again, it gave us like this good formatted response, which it does like automatically. We never asked it to do. We never told it how to do it, but it does. Let's actually go to one of the links as well. Very curious. It's actually a blue shirt. So the API works. There's no LLM magic here. It's just the search product function that we have which works. So yeah, these are the 3 shirts, and then the final answer is the same. There is no answer, but there is no answer colon to get it, but this thing still works. If there is no answer, it will just split it, try to get the answer still, and even if answer is not there, it will still get you this content that it generated and the last response. But I hope this part is clear. So when we get this response, and this response is the response that LLM gave us for the last message in the loop, which is typically the answer and not some action, right? and that is the response that we return from our chat function as well. So now let's start adding it to the cart as well. Now that we have the history, let's actually see the messages as well. So if you see these messages, we are adding the in this chat function that we are calling. We are adding the query, we are adding the React loop history to it. So let's see how that is added. So first the query is added, which we had entered. And now this is the assistant thought and action. If you see here, there is action. So this is the this is coming from React loop history. This is the first thought that it had, and then we add the observation under user role, and then again we add an assistant message. This is the final answer that it generated. This is the formatted one. So these are all appended in the React loop history, which the React loop function returns, and we are appending it to the messages. So now all this history will go on if we call another query now. So let's ask it something like, let's add third one. So this is a query again that I'm asking it to add to the cart third item. So it says like the user wants to add third product to the cart, but they have not specified quantity. I should ask for the quantity. How many units of now you see it has history, and when I ask it to add the third one, it knows like which one user is talking about, because in the chat history when it's happening, this is the third item, right? So it's taking this t-shirt and asking me about how many t-shirt. Like for all purposes you can completely ignore this part because these are just logs for us, and this will be the actual output of the chatbot that it's there. So it's asking us the quantity. Let's tell it 2. Great. So okay, something amazing has happened here. Let's go through this. This is where the response starts. So now it calls for an action. It didn't even go for the thought. It just directly says action, add to cart this item, and quantity is 2. So we'll call the add to cart function. We'll return observation as true, result for calling. So now it's giving an answer. It's basically saying this product added to the cart with quantity 2. Would you like to proceed with the purchase or need anything else? Now the most interesting part is when you see messages. Oh, I got too excited, I guess. Now these are again getting added as history, right? We maintain a history here in messages. That's why we are able to say like by third one, by 2 quantity. So here if you see, right? So here we were given options. We are saying let's add third one. An assistant is saying okay, but how many quantity? We are just saying 2, and because of all this context, it knows that it needs to add 2 quantities of this product. This is the most interesting part. It saw the history and it saw this third product has the product ID of this B07MG whatever GUIM, and it picked that exact ID, and it gave and it used like add to cart with this ID, and quantity is 2 because we specified 2. This is just beautiful, amazing. This is AI. I am very much amazed with this. Like this looks like magic to me, honestly. But then yeah, we have added like I think we can print cart as well, so we can see like this product has actually been added to the cart with quantity as 2. This is just too good. I don't know like how to define this feeling, but if you understand like till here how everything is working, the history, the reaction, the React loop, everything just falls into place. So we can let's not leave our bot hanging still, even though it has excited us a lot. It's asking like do you want to purchase or do you want to add anything else? Let's make it a little interesting, saying actually let's add first one as well with one quantity. Okay, great. So it's adding first one as well. Let's check if the ID is picked correctly. B00NO, B00NOY looks correct to me. You can tell if anything is wrong, but it's actually picked the ID, picked one quantity, and added it to the cart. It's calling the add to cart function. Now we can actually go ahead and ask like what all is there in my cart. Let's see how it goes. So it's calling summarize cart now. It said like action summarize cart null, and we'll call this tool. The tool will return basically whatever cart item that is there. You can also refer to the functions if you get confused, like how the functions work. The actual Python functions that we wrote, it will just return the cart variable that we have, and now it will properly summarize like you currently have the following items, and you see it replaces the ID with the title. I don't know if you seem to be impressed by this or not, but it has all the history, so it knows like which ID is mapped to which exact product. And in our cart, when we return the cart, when it only observes the product ID, if you notice. But when it tells us about the cart, it is replacing the ID with the product title, which is just too good. I feel excited with this. I don't know. So now that we know what all things we have in our cart, we can ask it like, let's check out. Okay, great. The user wants to proceed with purchasing the item on the card. I need to confirm the payment method. Would you like to choose? So it's asking like, it's giving an answer. It gave a thought, but it didn't perform any action yet. It's asking like, which payment method would you like to purchase? For the purchase, you can choose the following options: cash on delivery, credit card, debit card, UPI, or net banking. Isn't that just too good? So it's asking from that enum, which payment method do we want? Maybe we can choose net bank. So I purposely typed net bank rather than net banking. Let's see how it goes. Great. So it actually uses like net banking. Is that how we wrote it in the prompt? Let me quickly go and check. Yeah, so if you see in the prompt, we had mentioned like an enum. So payment methods can only be these types, and we don't have a space between net and banking. So even that it picked, and I just said net bank, which might not be very accurate, but still it picked, and it's like, oh, I need to call net banking. Yeah, so the way our function works is it'll just give a payment link for net banking. I don't know if this is how net banking actually works, but while implementing the actual function, if someone has chosen net banking, you'll of course have a sophisticated function to handle that case. And it will give you the final payment link, and it has also formatted the link for us properly. This is like HTML, markdown. Yeah, so we can go and make the payment. So I hope it might be a little tricky, but if you go through the code, there's only two major functions: the React loop that we use, and this small function is also a function. So even this chat function cannot be ignored, but it just keeps track of messages and keeps appending to it. Whatever new message comes, it'll add it to the message and pass everything to the React loop. Now the React loop, it'll add a system message to it always. So this question message can be like one question or the complete history, right? And on top of that history, we have this React instructions of how we want our LLM to think, act, observe, and all, right? So it will keep executing this loop till it finds a nice answer for us to give to us. Maybe as a last experiment, I would like to chat more, but let me just reinitialize messages for now. So I'm erasing all the history. So now we can start like a fresh chat basically. So let me write down this little bit complex query and see how it does. Like basically we are giving it all the information in one go itself. Let's see how it does. I was also very curious about this. So we are asking it to buy 2 shirts with cash on delivery. I need to search for shirts first. Order suitable option, user purchase. I'll add. Okay. So, okay, it did add to the cart one of the shirts with one quantity, and it's also executing buy order. 2 shirts has been successfully purchased with cash on delivery. Order confirmation has been sent. Great. So it's added like different shirts. Yeah, it's added different shirts. But you see, like it didn't intervene in between. It took its decision. So this is the loop that it was running, right? It went into the thought. It took the action of searching the product. It observed that these are the shirts that are available. And now when again it went back to the start of the loop, it didn't ask like which shirt do we want. It just added to the cart like one shirt, one of the shirt with one quantity. And then when we observe true, again it's added like another shirt with one quantity. Again it observed true, and then both shirts have been successfully added. Now I need to proceed with the purchase using cash on delivery. So it called like buy product COD, and then yeah, observation is basically order confirmation sent to you. Basically, this is like completely automated, like single query. The agent took all the actions it needed till it reached the final goal, which is ordering using cash on delivery for 2 shirts. In the previous example, we were giving like simple queries, so it was doing like one task and then asking like what do you want to do next. But here it just went on full on, and it just added everything. So yeah, this is like I don't know, like I feel very happy looking at this. I hope you are also as excited as me. I hope you understand this project. Like if you don't, like maybe watch the video again, maybe go through the code. I'll attach the link in the description to the code. Do consider liking this video and subscribe to the channel as well. Maybe if you want to connect, I'll give my LinkedIn as well in the description. Thank you guys. Bye.